All right, in this lesson, we're going to learn how to find the area between two curves. But before we dive into that, let's do some review on how to find the area between one curve and the x-axis. So, this first question is asking us, how do you find the area of this line from A to B? All right, so the question is asking us to find this shaded region right here. And we know from previous lessons that the area is also equal to the antiderivative of, I didn't even name this graph. Let's call this graph f of x, or this line, f of x. So as I was saying, from previous lessons, we have learned that the antiderivative is also the same as finding the area. So if you write the antiderivative of f of x, d of x, from A to B, we also know that we are writing the equation of the area from f of x from A to B. Now, using the second fundamental theorem of calculus, we also know that little f of x is the antiderivative of big f of x, or is the derivative of f of x, sorry. And by using that logic, we also know that capital F of x is the antiderivative of little f of x. And we know that to find the area of this shaded region right here, we have to subtract f of b from f of a. And this is how we're going to find the area of this shaded region from A to B. Now, we can also use this logic to find the area between two curves. So let's jump into it. So, using this first graph, the question is asking us, what is the area between the two curves from A to B? All right, in this scenario, both of the lines have positive area. Let's label these lines. Let's call this first line f of x. Let's call the second line g of x. Now, before we get into solving the problem, let's understand what the question is asking us. So, if we want the area between two curves, that means that we want this shaded region right here. And the area we don't want is the area from g of x to the x-axis. Sorry, I forgot that word for a second. So first, let's think about the area of each line. So, the area of f of x from A to B is going to give us this shaded region right here. It is going to give us the area from between the curves, but it's also going to give us area that we don't want, which is right here. But we also know that looking at g of x, it is going to give us this shaded region right here, which is the area that we don't want. So let's think about this. The area of f of x from A to B is going to be this shaded region right here, which includes area that we don't want. But if g of x's area includes the exact area that we don't want, if we subtract f of x's area from the area of g of x, we are going to end up with the area only between the two curves from A to B, which is what we were looking for in the first place. So let's see how we would solve this. From the question above, we know that the antiderivative of f of x could also be written in this form. F of b minus f of a, subtract it by g of a from g of b. So, to find the area between the curves, you would find the output of f of b and the output of f of a. And you would subtract that from the output of g of a from the output of g of b. I know it sounds confusing, but we have done this before. It's just a little bit more complicated. Let's look at another scenario. All right, this question is asking us, what is the area from C to D? All right, C to D. All right, and looking at the area of f of x and g of x, we see that f of x's area is going to be positive, and g of x's area is going to be negative. So how do we solve for the area between these two curves if one area is positive and the other is negative? Well, let's see if the equation we set up in the last problem is going to work this time. So, antiderivative f of x, d of x from c to d, subtracted from antiderivative, which also means area, of g of x, d of x from c to d. Okay, now let's think about what the values of the area is going to be. We know from looking at the graph that f of x's area is going to give a positive value. And we know that g of x's area is going to give a negative value. But we also know that there's a minus sign right here. And using basic algebra skills, we know that two minuses make a plus. So basically what we're doing here is we're going to add the area of g of x to the area of f of x, which is going to give us the area between the two curves, which is what we wanted to find in the first place. All right, let's look at the last scenario. What is the area from M to N? I'm going to label f of x and g of x. All right, so let's think about what f of x's area is going to be. So looking at f of x's graph, from the line to the x-axis, f of x's area is going to be this shaded region right here. And g of x's area is going to be this shaded region right here. Okay, so the area we want is this right here. This is the area that we want because it is between the two curves and between M and M. And the area we don't want is f of x's area. Now if f of x's area and g of x's area both include the area that we don't want, how do we get rid of it? Let's try using the equation that we've used in previous problems, see if it works for this scenario also. All right, so antiderivative of f of x, d of x from M to N minus antiderivative of g of x, d of x from M to N. And again, to clarify, this also means area. Okay, so let's think about this. F of x's area is going to be negative, and it is going to include it is only going to be the area that we don't want. And g of x's area, we know, is also going to be negative. But again, like the last problem, there is a minus sign right here, and g of x's area is going to give a negative value. So what we're going to end up getting is a positive value. So let's think about this. If g of x's area is going to end up being a positive value, and f of x's area is going to be a negative value, essentially what we're doing is we're using f of x's area to take away the area that we don't want and end up getting the area that we do want. So in the end, we are going to get the area between these two curves because f of x's area, I know it sounds redundant, is going to take away the area that we don't want. And again, if we were going to solve this using values, we would subtract capital F of B from capital F of N from capital F of M. And we're going to subtract that from capital G of N from capital G of M. Now we would find these values and really all we would have to do is just plug the numbers in if we had values. And we have just run through three scenarios. One where both of the areas are positive, one where the area is positive and the other area is negative. and the first scenario where both of the areas were positive. And this is how you find the area between two curves. Thank you.